Hi there, this is a video about function inverses. And what we want to do when it comes to function inverses is a couple of things. All right, a few things come to mind when I think of function inverses. And that is first to rewrite f of x as y, okay? And then you switch x and y and then solve for y. All right. So that's probably the first thing that you want to write down when it comes to function inverses. The one thing that I want to do here is let's calculate the inverse. So find the inverse of x given a function f of x is equal to, say, oh gosh, let's do 3x plus 1. All right, like that function 3x plus 1. So here's what we want to do. All right, let's use this methodology to show you what I mean. All right, and so this notation here, f inverse, or f to the negative 1 of x, is the inverse of f of x, okay? And so what I want to do, let's first do this. All right, let's rewrite f of x as y. So let's take this example here, and I'm going to write this as y is equal to 3x plus 1. Now, the next thing I want to do is I want to switch x and y. So switch these two values, and we're going to get that x is equal to 3y plus 1. Now, once I've switched that, let's solve this equation for y by subtracting 1 from both sides. So x minus 1 is equal to 3y. Divide by 3 on both sides. So you end up getting that y is equal to x minus 1 over 3, or you could write that as y equals 1/3 x minus 1/3. Okay, and so from here, all right, once you've done this solve for y, let's put this back into function notation now. Because this is our inverse, all right, we want to write it in inverse function notation. Okay, and so now we get that f inverse of x is equal to, and we can write this a bunch of ways, but I'm going to do x minus 1 all over 3. All right, so that's our function, that's our inverse. Now, if we have a function and its inverse, okay, let's say, you know, that we've got this. We've got f of x is equal to 3x plus 1, and then we've got f inverse of x is equal to x minus 1 all over 3. What we want to do now is we want to calculate f of f inverse of x and do a composite function from a function on its inverse, okay? And so from here, all right, I'm going to take my function here, and I'm going to plug that into x of my other. So I'm going to take this entire function here, plug it into x of my other function, and so we're going to get 3 times, all right, in this case, the quantity x minus 1 all over 3, all right, and then plus 1. All right, so from here, what we can do, your 3's divide out. So 3 divided by 3 is 1, so you're just simply left with x minus 1 and then plus 1. And negative 1 plus 1 is 0, so you just get x. All right, so when you have a function and its inverse, you get, and you do a composite function, you should just get x out of that. And that's always going to work if you've calculated the inverse correctly. All right, let's talk about why this works. Okay, so when I graph my original function, y equals 3x plus 1, that's my red graph here. When I plot my function x minus 1 over 3, that's my blue graph here. Now, what we notice about these points is that, or these two graphs, is they are reflected over the line y equals x. Okay. Now remember that that's what we got when we do our composite function. All right, and I want you to notice something. I want you to notice a point that's on the graph here. All right, this is the point 1, 4. All right, I want you to notice that this is the point 4, 1. Notice that the x and y values are simply switched from one to the other. All right, and that's a really important thing to see when we're doing function inverses. All right, let's do another kind of trickier example to determine the function and its inverse. Okay, so we want to find the inverse function if f of x is equal to x squared plus 2. So first thing I want to do is let's rewrite f of x as y. So y is equal to x squared plus 2. All right, let's then switch x and y. So x is equal to y squared plus 2. And at this point, let's solve this equation for y. So I'm going to subtract 2 from both sides. All right, and we're going to get x minus 2 is equal to y squared. Now, when we do this, we want to take the square root of both sides. All right, so as a result, we're going to get that y is equal to plus or minus the square root of x minus 2. All right, and at this point, we'd want to write this as f inverse of x is equal to plus or minus the square root of x minus 2. Now, this itself is not necessarily a function. All right, let's look at this on Desmos to see. Okay, so once I plugged this into Desmos, and I wanted to plug in my original function, x squared plus 2, and then when we calculate the inverse of this, all right, we have to account for both the positive and negative square root, okay? Because here's our original function, okay, and then here is our inverse. Now, our inverse is not a function, all right? So this technically is not a function, all right, because it doesn't pass the vertical line test, all right? And plus we have to get two different, we have to account for both the positive and negative. So the question that we are then asked is, how do you determine if a function's inverse is going to be a function? And we call this the horizontal line test, okay? And if I draw in a horizontal line on our function and it crosses 2 points, so the horizontal line test is done on the original function, and if it fails, so if it fails, like in this example, then f inverse of x is not a function, okay? If it passes, then it is a function. So it's kind of a weird thing, but that's the idea. So whenever you have a function and you find its inverse, it may not be a function, okay? You can check to see by calculating the inverse, or you could simply just do the horizontal line test and go from there. So hopefully this makes sense and it helps. Please reach out if you have any questions. Thanks a lot. Bye.